Hi students, welcome to Vari Medical Academy. So, உங்களுக்கு எல்லாத்துக்கும் ஒரு குட் நியூஸ். Vari Medical Academy சார்பாக இனிவரும் நாட்கள் டெய்லியும் ஒவ்வொரு டாபிக் நம்மளுடைய faculty members லைவ் வீடியோ ஸ்ட்ரீம் உங்களுக்கு கொடுக்க போறாங்க. Wish you all the best my dear future doctors. டாபிக் ஏதாவது வந்து கிளாரிட்டி வேணும் அப்படிங்கிற எந்த கண்டென்ட் ஆனாலும் கமெண்ட்ல தெரியப்படுத்துங்க. அதுக்குண்டான சொல்யூஷன் Vari Medical Academy சார்பாக கொடுக்க ரெடியா இருக்கும். இந்த மாதிரி வீடியோக்கள் உங்களுக்கு பிடிச்சிருந்தா மறக்காம லைக் பண்ணுங்க, சப்ஸ்கிரைப் பண்ணிக்கோங்க.
Welcome students. So my name is Gopal. I am working as a chemistry faculty in Vari Medical Academy. So the topic is electronic displacements in covalent compounds, that is organic compounds. Okay. So we have seen that organic compounds are covalent in nature, right? So the compounds will be formed by covalent bond. Okay. So this covalent bond, as we seen, the mutual share of electrons will take place, right? So if a carbon is bonded with one more carbon in single bond, that is covalent bond. Okay. So this carbon has shared one electron and this carbon has shared one electron. So in terms we will get one bond, that is covalent bond. Okay. So we have seen that ionic compounds, right? Ionic compounds are in ionic form. So for example NaCl. So NaCl is ionic compound, right? So it will give Na plus then Cl minus, right? So this is ionic compounds. Whereas in covalent compounds we could not see that positive and negative ions, right? So that's why we can say this covalent bond. So this one is ionic bond and this one is covalent bond. Okay. So today we are only focusing on covalent character, right? So that's why. So how the covalency is being formed in organic compounds? What are the electronic displacements? Okay. So there is some displacements taking place in these organic compounds also. Okay. So this elucidates or this explains the overall effects, right? Which is occurring in covalent bonds. In other words, sigma bonds. Okay. So this covalent bond can be utilized or can be influenced by atoms or which are groups. The electronic displacements can be obtained. Okay. So for example, for the reason is due to atoms or groups which causes electronic displacements in organic compounds. Okay, so these atoms and groups are only possible or only reaction or only repeated groups will form electronic displacements. Okay, so in other words, like we can elucidate as a inductive effect. This one is inductive effect, and next one is base electromeric effect. And C is mesomeric effect. And D is hyperconjugation. Okay. So these are all four effects which will possible or which is emphasizing the electronic displacements in organic compounds. So as we seen, this electronic displacement is only possible some other atoms or groups is present in carbon-carbon bond. Okay. So these are all the effects: inductive effect, electromeric effect, and mesomeric effect, and last one is hyperconjugation. Okay. So inductive effect. So firstly we are going to see about inductive effect. Okay. So due to some atoms or groups which is causes electronic displacement in organic chemistry. Okay. So first one is inductive effect. Okay. First one is inductive effect. Inductive effect is nothing but when Inductive effect is nothing but when the electronic displacement taking place in sigma bond. Okay, so that is permanent effect, so which can be explained in detail. Okay, so first one is inductive effect. Okay, so for example, C. So this is a carbon chain, right? So butane, this is butane, N-butane. Okay, so since all atoms are same, so there is no any effect, right? So in main chain we have carbon, and another one is hydrogen. So there is no any that much inductive effect is taking place, because the inductive effect of hydrogen is assumed to be 0. So there is no any inductive effect is occurring in this compound. Okay, so where in some other molecules, for example, one chlorobutane. Okay, so here the chlorine atom is attached in this carbon skeleton or carbon chain. Okay, so here the carbon and chlorine is directly bonded by one covalent bond. Okay, so since this chlorine is more electronegative than carbon, so it attains partially negative charge. Okay, so which polarizes this first carbon as partially positive charge. Okay, and next one, this carbon can influence this carbon as doubly polarizable, and this one is triply polarizable carbon. Okay, so after that, after 3 carbons, there is no effect. After third carbon, there will be no inductive effect. Okay, so after third carbon, this is first carbon and second one, third one. So here there will be no inductive effect is witnessed. Okay, so once again, so this carbon is N-butane. So carbon is in main chain and the hydrogen is bonded with this carbon. So the inductive effect of hydrogen is assumed to be is equal to 0. So there is no any polarizability is attained. So this is non-polar. Okay, this is non-polar. Whereas in this compound, the group chlorine or the atom chlorine is attached to direct carbon chain. So in this molecule, the chlorine has more electronegative than carbon skeleton or carbon atoms. So it will pull the electron density over this carbon skeleton. Then it will polarizable. This we can say it is as dipole. It will act as dipole. Okay. So since the polarization is taking place, so it is first carbon, so the polarizability will be maximum in first carbon, and the second one will sense some slightly polarizability, and third one is minimum. Okay, very meager amount of polarizability or meager sense of polarizability will be experienced. Okay, so the magnitude of inductive effect directly proportional to distance. So magnitude of inductive effect is directly proportional to distance. So this is very, very important one. Okay, so it is only depends on distance. Okay, so this is all about the inductive effect. Okay, so here we can divide this inductive effect into 2 subsections. Okay, that is positive inductive effect and next one is negative inductive effect. Okay, so here A is negative inductive effect and B is positive inductive effect. Okay, so the negative inductive effect, first one is negative inductive effect, as we seen before, the same concept. So here the carbon and some X atom is there. So we are assumed to be that one chlorine. So it will slightly minus charge and this will have a positive charge, right? Okay, so this one is first carbon and second carbon, third carbon. Okay, so the direction of electron shifting is in towards chlorine. Okay, so and here the direction of shifting sigma bond electrons towards this carbon is taking place. Okay, so the magnitude is lesser than second one and third one, right? Because the inductive effect is directly proportional to distance, right? So carbon, third carbon will sense minimum amount or a very minimum sense of inductive effect. So the direction towards chlorine. So if this atom is withdrawing electron from the carbon skeleton, that effect or that groups are called as minus I groups. Okay, so the atoms are groups withdrawing electrons from carbon skeleton are known as minus I groups, and the effect is minus I effect. Okay, students, so this is very important one. So negative inductive effect. Okay, so the negative inductive effect is the atoms or the groups is withdrawing electrons from the carbon skeleton. Okay, so the electrons are withdrawn by the groups or atoms is known as minus I effect. So these groups are minus I groups. Okay, so as we seen before, minus I groups, about minus I groups, right? So those are all electron withdrawing groups. Electron is withdrawn from carbon skeleton. So this is the correct trend. Okay, this is the increasing order of or decreasing order of the minus I groups is given. Okay, so sir, there are many groups, right? So these groups starting with ammonium salt or ammonium and sulfur salts. So these are all electron withdrawing capacity is maximum. When we go down, the electron releasing capacity is increasing. If we start from OH, so here the OH will have lone pair of electrons, right? And amine has lone pair of electrons. So this trend which shows somewhat electrons are donating. So if this is actually we are seeing electron withdrawing group, but the capacity of OH and NH2 is somewhat is electron donating nature. Okay, so here we see that OH will act as plus R effect in resonance effect. So these two groups are somewhat electron donating capacity having groups. Okay, so this trend is very important one when the this is very important trend. Okay, so ammonium salts and sulfur salts, this is also ammonium, this is trialkyl ammonium salts, ammonium salt, nitronium ion and sulfur oxides and cyanides, aldehydes, alcohol and carboxylic acids, halogens. So these groups are electron withdrawing groups, in other words minus I groups. Okay, so next one is plus Psi effect. Okay, so plus Psi effect, the groups are the atoms which release electron cloud to the carbon chain is known as plus Psi groups. Okay, so the effect is known as plus Psi effect. Okay, so here that's carbon skeleton is there, we consider this X atom. Okay, so if this X atom is donating electron to this carbon chain, so then we can consider this atom as electron donating group. Okay, in other words plus I groups. Okay, so this effect is known as plus Psi effect. Okay, so this is the plus Psi effect trend where the O in minus, so this minus I will say that electrons are released from these atoms or groups. Okay, so here you can see, so D, right? So the D is deuterium, the isotope of hydrogen, and next one is hydrogen. See, here is also the hydrogen is at last the minimum end, and this is also here. So that's why we are considering hydrogen, the inductive effect of hydrogen is 0. Okay, that's why we are putting in last one. Okay, so next one is the core point, very important points all about this inductive effect is the polarization of sigma bond is taking place. What? The polarization of sigma bond is taking place by due to the electronegativity differences between two atoms, which causes or which results the dipole formation. Okay, so this dipole formation is known as inductive effect. By the electronegativity differences, by means of electronegative differences, the inductive effect is established by means of dipole created. Okay, so the polarization of sigma bond is taking place due to differences in electronegativity. As we seen, the carbon is bonded with chlorine, so the chlorine will be maximum electronegative, right? That's why the electrons are pulled over by chlorine. So it will possess partially negative charge and carbon will possess positive charge. So this will in plus I group, this is contrast to minus I group. The atoms are which releasing electrons to the carbon chain. Okay, so the electrons will be released by these atoms to the carbon skeleton is plus I groups. So these are all the groups which releasing the electrons. Okay, so this is decreasing order, or the trend is very important one. So the core point, as we discussed, this is very important one is permanent effect. So the inductive effect is very permanent. Okay, and it is distance dependent. Okay, so if the distance is increasing, the ability of the magnitude of inductive effect will be decreased. Okay, so that's why we are putting this one as distance dependent effect. And next one is electrons will be reside in the original atomic orbital. The electrons will not shift to any other atoms. Okay, so the electrons will resist or will be there in its original atomic orbital. There will be no change in electrons. Okay, so it will stable in that original atomic orbital, but the cloud will be changed. Okay, by the dipole creation. Okay, so this is very important one. Electrons will be stayed or will be resist in original atomic orbital. So the core points are very important one, and this minus I and inductive effect will say that stability of carbocation, right? Stability of carbocation and stability of carbanion and acidic strength of aliphatic carboxylic acids and aliphatic organic compounds. Okay, so this inductive effect is very important to establish the stability of carbocation and stability of carbanion and acidic strength of aliphatic compounds and aliphatic carboxylic acids and organic compounds. Okay, so next one is how we can establish the stability of carbocation. That's we are going to see next one. Okay, so applications of inductive effect. The first one is stability of carbocation and carbanion and the two carbon free radical. Okay, and acidic strength. And third one is basic strength. Okay, so these are all the application can be established or can be determined by this inductive effect. Okay, so first of all, as we see that carbocation, stability of carbocation, right? So stability of carbocation is determined by the plus I groups. Okay, so in other words, plus I groups are electron donating groups, right? So electrons are donated to carbocation. For example, so this is a molecule which has positive charge, and next one is, okay, this is also one more carbocation, and okay, if you consider this type of carbocations, so see this carbon is bonded with 3 methyl groups, right? So this is tertiary carbocation. Tertiary carbocation or 3 degree carbocation. This one is 2 degree carbocation and primary carbocation. This is methyl carbocation. Methyl carbocation. Okay. So look into here. See, there are 3 methyl groups. Methyl groups are nothing but methyl groups are plus I groups. Correct? So these methyl groups will release electrons to this carbocation. So the electrons will be there to this carbon. So the carbon is in positive state. So positive state means, as we seen in previous classes, carbon is in when the carbon is positive state, the carbon is lack of electrons. So the lack of electrons or the lackness is utilized or nullified by the electron donation of plus I groups. So these groups will donate electron to this carbon, so it gets somewhat stability. So here there are 2 plus I groups, only 1 and 2, here 1, and there is no any plus I groups. So the plus I groups, if the plus I groups are maximum, like if you see plus I groups directly proportional to stability of carbocation. Okay, if the plus I groups are maximum, then the stability of carbocation will be maximum, because this plus I groups donates electron to that carbon. The electron deficiency will be satisfied by donation of electrons by plus I groups. So there are 3 groups, here 2 groups and only 1, and there is no any plus I groups in methyl free radical. So the stability will be maximum for this one and this one, then this one. Okay, so this is very, very important, students. So when the plus I groups are maximum in carbocation, so that group or that carbocation will be more stable. So in many competitive exam, they will give some 4 carbocations and which one is more stable. So there, without any confusion, you have to assume that if the carbocation is consist of plus I effects or plus I groups, so then that carbocation will be more stabilized one. Okay. So and after that, so there are plus I groups. Okay. So next, which one having more number of plus I groups? That will be more stabilized one. The first thing is you have to look at where the plus I groups are there and the which carbocation is having plus I groups, and next step is how many plus I groups are there, okay, or how many minus I groups are there. So that will explain the stability of carbocation. In other words, when the minus I groups are there, the stability of carbocation is very less stable. Okay, so minus I groups inversely proportional to stability of carbocation. How could we explain this one? The carbocation itself there is the deficiency in electrons. Again, if an atom or group is withdrawing electrons from that carbon, will destabilize that carbocation stability. Okay, if we consider this one NO2 and this one is CH3, and next one is if we assume these 3 types of carbocations, so the 3 groups are minus I groups, right? These 3 groups are minus I groups. So these groups will withdraw electrons from the carbon. Okay, so the carbon is in positive state, there is electron deficiency. Again, these groups are withdrawing from that carbocation, so it will destabilize that carbocation. So the stability of carbocation will be lowered. Okay, so that's why the minus I groups will inversely proportional to stability of carbocation. So this is also electronically less species, and this is also very eager to get withdrawn the electrons from that carbon chain. So this is opposite to each other. That's why the stability will be minimum to this one, and this carbocation will have more stability. Okay, so this is all about today inductive effect or application of inductive effect. So as we see in the plus A groups, how it is performing in stabilization of plus A groups, and minus group, how it is performing as stability category of or stability phenomena for this plus A groups and carbocations. Those things have been discussed today. So further classes, that acidic strength and carbanion, those things are discussed later. So this is all about today. Thank you, students.